Hello friends! As you've already mentioned, there are some videos on my channel where I test the different types of DC-DC step-up or step-down converters. In this video we will also test one of such devices. This is DC-DC step-down converter, which is designed for 12 amps. Let's connect it to the power supply, connect the load to this device and test it. Now everything is connected. The power source voltage is 14 volts and the output voltage will be adjusted to 8 volts as one of these car bulbs is designed maximum for this voltage. First of all, let's connect this car bulb, which is the most powerful one. 3.1 amps, 4.4 amps, 7.9 volts. Let's increase the load. The input amperage is 4.4 amps, output amperage is 6 amps and the output voltage is still almost 8 volts. Let's measure the temperature. So this is the maximum temperature. As to the sound, an audible buzz, it comes not from the device but from the power supply, because its 12 volt output is adjusted to its maximum voltage. Let's increase the load. Input amperage 6.8 amps, output amperage 8.5 amps. As to the output voltage, it amounts to 7.8 volts. Let's measure the temperature. Well, this is the maximum temperature for this mode. Let's increase the load. So the device can withstand the output amperage of 11 amps, but the output voltage has decreased. As to the temperature, so here is the maximum temperature. In case of the output amperage 12.3 amps, the output voltage amounts to 7.4 volts. That's not acceptable. Let's measure the temperature and then decrease the load. Well, this is the temperature. As you see, the temperature was too high and it's necessary to decrease it and then to continue the test. The maximum temperature now is acceptable. Let's remove some car bulbs and continue the test. And let's accept the maximum difference in voltage of 0.2 volts. (7.9 volts), output amperage is 8.5 amps, and now let's increase the load slowly. In case of 11.1 amps, the output voltage is 7.8 volts. Output amperage is 11.2 amps and output voltage is 7.7 volts, which is not acceptable. So 7.7 volts also is not acceptable. But also in case of these 4 car bulbs, the output voltage decreases. Let's decrease the load. Let's measure the temperature. So this is the maximum temperature. Let's turn our cooler on. And as we see, the voltage has a bit increased. Now let's increase the load. 9 watts. It's okay. 10 watt car bulb. The voltage is the same, 7.8 volts, and the output amperage is 9.8 amps. So the device definitely had a cooling problem. Let's add one more car bulb. The voltage even increases. Let's try to measure the temperature. Well, this is the maximum. Now I'll add one more car bulb. Let's add this one. The device can withstand such load, but only in case of presence of the cooling solution. However, even the cooling solution isn't sufficient for stabilization of this voltage, because finally the voltage decreases. Let's check the temperature. 61. And it seems in case of output amperage of 10.8 amps, the difference between the initial voltage of 8 volts and the current voltage is really stable. Let's once again measure the temperature. The maximum temperature is not more than 63 degrees, and in case of the above mentioned difference of 0.2 volts between the initial voltage and the current voltage, the maximum amperage this device can provide is 10.8 amps. Now let's define the maximum amperage in case of voltage difference of 0.1 volts. Let's increase the load a bit. The output amperage is 7.6 amps and the output voltage is still 7.9 volts. Now the voltage changes. Let's decrease the load. This is the weakest one. Anyway, voltage is not stable. In case of a difference of 0.1 volts between the initial voltage and the current voltage, the maximum output amperage amounts to 8.2 amps. Let's measure the maximum temperature in this mode. Here it is. Also, let's check the behavior of this device without the cooling solution in this mode. Input voltage amounts to 11.6 volts, input amperage is 6.9 amps, output amperage is 8.2 amps. So without the cooling solution we see that the voltage becomes not stable and decreases sometimes. And here we have the reason. Even 60 degrees. Let's turn the cooler fan on. And now we see, as soon as the temperature of the device is considerably decreased, the output voltage is stabilized to our target voltage. Naturally, you should use the cooling solution in case of the currents more than 5 or even 4 amps, and in such conditions you'll get really decent results. Once again, input voltage 11.6 volts, input amperage 6.9 amps, output voltage 7.9 volts, and output amperage 8.3 amps. As to the conclusion, of course there is no question of 12 amps and even of 11 amps, but the device can provide stable 8 amp output in case of applying of the cooling solution. In case of additional questions, please write them in the comment section. Thanks for watching. Wish you good luck.